Okay, so welcome to this week's Megaport Live Tech Drop-In session. The topic this week is MACsec and encryption in transit. So first off, we'll have a very brief kind of look at who Megaport is and how we fit into the picture, and then we'll have a look at encryption in transit. We'll do a bit of an overview, and then we'll have a look at three of the most common options, the ones that we actually practically see day to day, and then we'll have a look at specifically MACsec on Megaport and how customers use that and some of the different options and pros and cons. We'll do a quick demo, and then at the end, we will do a Q&A. So Megaport is a network as a service provider. Basically, what we do is we run a large global private network and provide services over that network in a cloud-aligned way. So we try to do for networking services what cloud providers do for servers and compute. Typically, customers will use Megaport to connect between their data centers or from their data centers to the cloud or between cloud providers. So as you can imagine, in that type of scenario, a lot of the time customers will want to encrypt that data. So encryption at transit refers to protecting data as it moves across a network from somewhere to somewhere else. There's a whole load of different options. There's kind of endless options and then combinations of those options that you can use to encrypt data as it moves from somewhere to somewhere else. There's all kinds of different pros and cons. You can do encryption at all different network layers, all kinds of different protocols. So it's a whole massive topic on its own. Probably something to add at the start here is that most modern applications use encrypted protocols already. So if you think about a web browser, when you go to a website, these days it's almost always HTTPS. So at one point it used to just be HTTP, and occasionally websites that needed to be more secure would have HTTPS, but now it's just completely ubiquitous. Basically all websites use HTTPS, and to the extent that a lot of browsers now will actually show a warning if a site doesn't provide secure connectivity. So that goes for other software as well. So many applications now, and many platforms already use encrypted protocols. They use secure protocols kind of by default built into the application. There's some more info about all this in a blog post that we published recently in the Megaport blog. So there's a link there at the bottom, or you can scan the QR code on the side there to go to that post to kind of read through the details. It goes into MACsec, IPsec, and TLS as well, and compares them and sort of goes through some pros and cons. So in practice, what we actually see tends to be customers using MACsec or IPsec or TLS or some combination of the three. As I said, there's many more options than this, and we have customers who use those other options. There's other types of tunneling protocols. There's things like WireGuard. There's other types of sort of over-the-top transport application layer stuff like Quick. There's loads and loads of options, and we kind of work with customers who do all of them and all kinds of different combinations. But really, these are the three that most commonly customers will use, at least in the most standard scenarios. And as a disclaimer at the bottom there says, even with these, there's different ways that you can use them. So you don't, like I'm sort of saying here, usually MACsec is for layer 2 and between switches, but not always. You can use it for other things and in other ways. But this is kind of what we typically see day to day. So MACsec, it operates at layer 2, so at the Ethernet layer. It encrypts traffic within the whole layer 2 frame. It's typically used between switches to encrypt traffic over a single hop. So if you have a switch and another switch and a cable between them, you can use MACsec between those two devices over that one hop to encrypt that traffic. The primary advantage of MACsec is that you can get wire speed performance. So what I mean by wire speed is that if you have 10 gig switches, 10 gig ports plugged into each other, you can enable MACsec and still get 10 gig. It's able to handle encryption that's very fast. So even some devices will even do MACsec up to 400 gig per second. So that's its kind of primary advantage. One of the caveats here, and something that we'll come back to a little bit later on, is that because MACsec encrypts the whole Ethernet frame, that includes it encrypting the VLAN tag. And that can be a bit of a complication for systems that need to read the VLAN tag because it's now encrypted, so they can't read it. So that's a bit of a, can be a bit of a limitation with some architectures, which we'll come back to later. IPsec, super common, basically a layer 3 sort of encryption. So at the network layer, typically between IP endpoints, typically between a firewall or a router or things like that, those type of network appliances. It's super widely supported. It's very, very common. All of the cloud providers have IPsec-based VPN services. You know, it's definitely the most common type of VPN in this context. Almost every type of device supports it, every type of router or firewall. The first complication there is that the configuration can be a little bit complex. It does pretty heavily depend on exactly the combination of devices you're using, and especially if they're the same on either end or not, or if you're using third-party services or different types of things. Part of that complexity is also that it's not just that you have to make it work, but that you have to make it secure. So there's a huge number of configuration options for IPsec, and some of them are not considered secure, and some of them may be considered secure now, but maybe not later. So you have to be a bit careful about exactly how it's configured to confirm that not only does it work, but it's best practice and secure. That's not a huge deal, it's something to bear in mind, but it's not a, not a deal breaker typically. The big thing with IPsec is that it can have a significant overhead. So there's a pretty big performance penalty usually for running IPsec. So that comes in two forms. The first form is that it adds a pretty significant header to the packets. So the amount of traffic you can send per packet is reduced. And so that's a factor. The other factor is that there's often limits on how fast the device or the service on either end can actually encrypt and decrypt those packets. So that's often something you run into, especially when you start to get up to 1 gig per second or more. If you're doing small amounts of traffic, if you're doing a couple of meg or a couple of tens of meg, or maybe even a couple of 100 meg, you usually find once you start to get up to about a gig per second or more, you can start to run into those limitations. There certainly are ways to scale that. So there's different types of solutions that you can look at to push more traffic over IPsec, either by scaling it horizontally or by using different types of appliances that can encrypt and decrypt traffic much more quickly. So it's not insurmountable, but it's definitely something to bear in mind that there is that, once you start to get towards a gig per second, you have to kind of really make sure that you're going to have the capacity that you need. The last one here is TLS. So TLS is the type of encryption that's used by HTTPS. So it's sometimes also referred to as SSL. It's a little bit different in that it typically is implemented at the application level rather than at the network level. So usually the client side for TLS will be something like a web browser or some client software on the actual end user's machine, as opposed to two network devices. I mean, it's possible to use it between two network devices. Like I said, there's sort of an infinite combination of possibilities here. But in practice, usually we see TLS as the client machine, the phone or computer or whatever it is, connecting through to a server. And they're the endpoints for the TLS session. So there's some pros and cons for that. A lot of the pros are, it's quite scalable. So because you're distributing that load, because every individual client machine is managing its own encryption, it scales very, very well. So, if you've got hundreds or thousands or millions of users and every individual user is doing their own encryption, it scales very well. Whereas if you try to have one device do the encryption for huge volumes of traffic, sometimes you can run into some capacity limitations. That also means because each device is managing its own encryption, you get encryption much more end-to-end, so much further down the path. So that traffic can stay encrypted all the way from the client machine, the laptop or whatever it is, all the way through the whole network to the actual web server or application server or whatever it is on the other end it's talking to. And it can be encrypted that whole way across the entire path, which is really most of the time what we're trying to get to. We're trying to maintain that encryption and maintain that protection for as much of the path as possible. And usually TLS gives you that. And fortunately, as I said at the start, often applications have this built in now. So you may find that your traffic is actually already encrypted, whatever traffic you're looking at. If you're if you're a network engineer, you might not have a view into it, but you might find that at the application level, that traffic is already encrypted. In addition to the encryption, TLS can provide identity services as well. You would have seen this when doing things like going to a website that has an expired certificate or doesn't have a valid certificate. You get that warning from the browser that says this connection's not secure. And TLS gives you that capability as well, again, because it's being managed by the client locally. So the actual machine that your user is on can confirm that that encryption is in place and is how it expects it to be, and provide feedback to the user if it's not. And that can be pretty useful from a security standpoint as well. The big caveat with TLS is that if it's not built in at the application level, it can be hard to bolt on. So it can be hard to sort of retrofit into an existing application or environment. It's often not impossible, and there's ways that you can do it. Things like SSL VPNs and that type of thing you can use to add it over the top, or there's different options there, but it's not something that can just be enabled at the network level and it sort of then works for everything. It's something that typically will be more integrated at the application level. The clients themselves have to be aware of it. It's tends to be a bit more of a process if it's not there already. So they're the three that we see, and they're the scenarios in which we typically see them being used. MACsec to connect between two devices on a single layer 2 hop, two switches usually. IPsec to connect between firewalls and routers and things like that over an IP network, can be the internet or a private network. And then TLS to connect between client machines and a server for that more end-to-end individual client-based encryption. So MACsec on Megaport. You can transport MACsec traffic over Megaport. You can transport any type of encrypted traffic over Megaport. For the most part, it's very transparent. So for the most part, we don't even see the traffic, right? We provide layer 2 transport. So most things like TLS and IPsec, other types of VPNs, things like WireGuard or other types of client VPNs, SSL VPNs, and that kind of thing. You don't really have to do anything from the Megaport level. That traffic will just seamlessly move across Megaport's network, and there's no interaction there between that traffic and Megaport, so it doesn't change anything that is encrypted. You just work like normal. The only caveat here is that, as I mentioned earlier, MACsec operating at layer 2, it encrypts the VLAN tag. So it actually encrypts the VLAN ID in the Ethernet frames. And oftentimes customers will use that VLAN ID within their Megaport configuration to be able to choose where traffic goes and which virtual cross connector gets sent down. So if you enable MACsec and that VLAN ID is encrypted, then Megaport can no longer read that VLAN ID, and so we can't use it to make decisions about where traffic should be routed. So the big caveat here is that if you use MACsec, the VXC must be untagged. So you can have a port with a VXC attached to it. If that VXC is untagged, which means it's configured to accept all VLANs, then we can accept MACsec traffic because we just accept the traffic. We'll accept any traffic that arrives on the port. If the VXCs are tagged, then every time traffic arrives, we need to read the VLAN ID to determine which VXC that traffic gets sent into. And if the VLAN ID is encrypted, we obviously can't read it. So that's the only caveat. Other than that, it pretty much works the way that you'd expect. You send the traffic in, we transport it to the other end and send it back out. It doesn't matter to us that it's encrypted. The actual application traffic, we weren't reading or processing it anyway. So it pretty much works the way you'd expect. The other factor is that, again, because of this functionality of MACsec operating in the port level and encrypting the VLAN IDs, cloud providers are also subject to that limitation. So cloud providers won't allow MACsec to be enabled on a hosted connection. So if you use AWS hosted connection or hosted VIF, if you use ExpressRoute, if you use Fast Connect to Oracle, Partner Interconnect to Google Cloud, because of this same limitation, because all of those services rely on VLAN tagging to separate different customers, and MACsec encrypts the VLAN tag, you can't use those services with MACsec. You have to use the dedicated versions of those services. So you have to use dedicated Direct Connect, or you have to use ExpressRoute Direct. You have to use the version of the service in which you get a dedicated physical port on the cloud provider side, rather than using the hosted version. And that's okay. We do support that. It's just something you have to bear in mind, and it can impact the cost of the solution pretty significantly. Depends on the architecture, but it's definitely a factor to consider. So this is kind of what this looks like. So we've got here essentially a very, very simplified view of two different network paths, from a client machine on the very left-hand side, going through its local router or firewall, default gateway type of device, through a switch to a Megaport port, across a VXC to another Megaport port, to another switch, router, a server. So this is kind of a simplified view. I mean, obviously, as you can imagine, there's obviously this sort of fans out, right? So there's, in reality, there can be multiple switches, multiple firewalls or routers, and then many clients. But this gives you a bit of an overview of how these different approaches work and the level at which they operate. So starting from the top, app level encryption, host level encryption, things like SSL, TLS, SSH, that kind of thing. They create this tunnel, they create this encrypted session from the client machine all the way through to the server that it's talking to on the other end. And there's an individual one of those sessions for every client machine and every server. For IPsec operating at layer 3, typically you'll have a tunnel from a firewall or a router across potentially multiple hops across a layer 3 network to another firewall or router or VPN appliance on the other end. And that tunnel will carry traffic from all of the devices behind the firewall and router on each end. In the middle, you've got MACsec operating between two switches. So you've got a switch on the left-hand side, a switch on the right-hand side, connected by a single layer 2 link. So in a physical sense, that link in the middle is really behaving like a big Ethernet cable. It's really just providing a transparent point-to-point layer 2 bridge between those two devices. And those two devices are running MACsec between them to create that encrypted path. So they'll encrypt any traffic that passes through those switches over that one hop. The traffic gets encrypted as it comes into one switch, gets decrypted out of the other switch. So it's only encrypted for that one hop in the middle. But using MACsec, the advantage of that is that those switches will typically be able to do that very, very quickly. Looking at the bottom section of the diagram, this is the same approach, but showing the objects that you'd be using if this was a cloud provider. So everything works the same. It's just these are the equivalent services in a cloud environment. So you can run MACsec, for example, to encrypt your traffic between your switch and the AWS switch at the edge of the Direct Connect service. So that'll do that one hop. Alternatively, you could run IPsec between a firewall, a router, or something within your network and the AWS VPN service, the site-to-site VPN service. Or you can run something like TLS, so HTTPS, or something like that from a client machine in your network all the way through to the actual service that it's talking to, which could be a VM, could be a load balancer, something like that within the cloud. So that's how that would look if you were to try and do this in a cloud environment. All right, so we'll do a quick demo. So this demo will basically be really just ordering the middle section, right? So ordering the ports with an untagged VXC between them, and then you can run MACsec over that to anything on the other end. So it can be a cloud provider, it can be another data center, whatever it happens to be in your case. So firstly, what we'll do is create a port. We'll choose a data center. Let's say that we want to choose maybe Colo City in Adelaide. Okay, we'll choose a 10 gig port. We'll call this DC1. Okay, and then we'll create another port. And in this case, we're going to choose maybe next DC S1 in Sydney. Okay, so we'll call this DC2. And we'll choose 100 gig for this port. So we'll order these services. And in this case, let's say that Colo City in Adelaide is our primary DC. Let's say this is where we are, where our rack is, or where our fiber service terminates from our premises. And this far side connection in NextDC S1, that could be because we have another rack in S1 that we want to connect to, and we're gonna run a cross connect from that port to our rack in NextDC S1. But it could also be that we want to connect to a cloud provider on-ramp that's in NextDC S1. So you can do that as well. It doesn't really matter too much what you cross connect this to. Could be your own equipment, could be a cloud provider, could be someone else's equipment that you want to run MACsec with. So that's basically how that works. So now that these ports are deployed, so these are all spun up and ready to go, we can download the LOA here to get the demarcation location in the data center and order the cross connect. Essentially, all we do now is we create a connection, choose private VXC. We want to connect to the other port that we created. And we want to make sure that this VXC is untagged so that Megaport doesn't need to read the VLAN tags. Okay. We'll put in a service limit. Let's say that we want to do 10 gig per second. Okay, and order. And so this will create that private point-to-point layer 2 link between the port in DC1 and the port in DC2. And then we order a cross connect from the data center from our rack to the port in DC1, and from the port in DC2 to our rack in DC2, or to the cloud provider on-ramp in DC2, or whatever it is that we want to connect to. So that could be AWS, could be Azure, whatever it happens to be. This is basically how you would do that, because you want to run MACsec and you need a dedicated port on the cloud provider side. That's why you have to do this. So under normal circumstances, you wouldn't have to do that. You can just choose AWS from the Megaport portal and connect straight to it. You don't have to do a port on the other end. You don't have to do a cross connect. It's just all automatic. But if you want to run MACsec, because you need a dedicated physical port on the cloud provider side, there needs to be a new port created and a new cross connect to the cloud provider, so you can have that dedicated physical port, because MACsec encrypts the VLAN IDs. All right. So let me have a quick look if there are any questions in the panel here. Okay. Okay. So does Megaport have GDPR or other compliance? Okay. Yeah. So yeah, that's an interesting question. So the answer is yes for GDPR, and we have some other compliance as well, like ISO 27001. Probably the best way to answer those questions is we have a service at trust.megaport.com. So if you go to trust.megaport.com, you'll see there's a tool there that you can use to run through a full security audit process. So you can essentially log into that portal. You can see all of the compliance certificates that Megaport holds. You can download the certificates. You can check things like penetration test results. You can kind of run through the whole process. You can see some other customer testimonials and things like that, and other people that have run through their own validation processes with Megaport. You can see cyber insurance information. It's basically got all of the stuff that you should need. It's got internal legal policies. It's kind of a whole all-in-one process. So this does come up pretty often, especially customers in highly regulated industries, things like banking and security and stuff like that. They'll typically run through this process. So you go to the portal at trust.megaport.com. You can log in there and you can kind of kick off an audit process, and that'll provide you all of the information that you need. That'll provide all of the documents and all of the certificates and things like that that you need. All right, let me have a look if there's any other questions. Does Megaport okay, right, cool. So the next question was, does Megaport do granular permissions within the portal? So the answer is yes, we do. There's a bit of a role-based administration structure. So essentially there's a process. So you can create separate user accounts. So every user within your organization will have their own account to access the Megaport portal. When you create those accounts, you can choose the role that user has. So there's all different roles with different levels of access. So all the way from read-only to company admin. There's technical roles and finance roles and things like that. So you can choose the role that user will have, and that'll control the permissions that they have access to within the portal. Otherwise, we do have some customers who require a lot more granular control. We have some customers who kind of want complete control over exactly what users can do. They want to do sort of separate service-based permissions, and they have very, very specific workflows that they need to have granular permissions over. So some customers have implemented their own management system, so that they'll build this into their own portals that they use, that they can maintain control over, and they'll use our API to orchestrate changes in the back end. So all of the services in the Megaport portal, everything the portal does, you can do via our API. So if you generate an API key, you can use your own tools, and then you can use that to sort of orchestrate who has permission to do what. You can kind of build your own layer over the top. And we also support SAML and single sign-on, so you can tie that into your existing identity provider as well, and use your own groups and user provisioning structures to manage that. Cool. All right. Okay, I think, it's already, okay, cool. I think that's probably all we actually have time for this time. So yeah, that's all. I guess we'll be back next week with another topic. Feel free to leave any comments. These videos get uploaded to YouTube now as well, so feel free to leave any comments there, so we can use that to basically drive the next sessions. Otherwise, feel free to reach out by website or email or however you want to do it. Reach out to your account manager if you're a customer, or yeah, via email on the website if you're not a customer. I'm always happy to help and talk through the details. But yeah, encryption in transit is definitely a big thing. Definitely comes up a lot, and yeah, we definitely have a lot of customers that use it in all kinds of different ways. So it's always interesting to see what customers want to do. Cool. Thanks, guys. That's all.